be working on the development of the cosine law. Now, suppose we have a triangle ABC. If we drop an altitude from A to side BC and label it H, it's going to be the opposite for the angle B in this triangle, let's call it T1, and this triangle, T2, for C. Now, in order to relate triangle 1 and triangle 2, what we're going to do is we're going to use that altitude to link the two triangles. And the result of that will give us something interesting to work with. So for triangle 1, if you start off with this, we're going to use the Pythagorean theorem to relate all the three sides of this triangle. Now, the hypotenuse is c squared, x is the base, and h is the height of that triangle. The reason why I call it x is because this side is A, and what I've just done is I've labeled the line, the baseline for T1 to be x, which means the baseline for this triangle here is A minus x. So now, when you take a look at triangle 2, its related sides using the Pythagorean theorem is this: b squared equals h squared plus a minus x all squared. And now, what we're going to do is we're going to take this equation and we're going to expand this bracket using the nursery rhyme song we did for this, for a minus x all squared. So you're going to call that this: h squared plus a squared minus 2ax plus x squared. So we square the first, square the last, multiply, and double to get the center part of that variable. Now, because we're adding, we don't need to keep the bracket. If there was a minus sign in front of that bracket, we would have had to keep the bracket and then distribute inside. So now, we said that the thing that linked these two triangles was the h term. So what we're going to try and do is we're going to eliminate the h term from this equation that I've labeled as equation 2. So equation 1 is going to be this equation solved for h squared. So now you're going to have h squared is equal to c squared minus x squared. So we're going to sub equation 1 into 2, and what we're going to end up with is something like this: b squared equals c minus x squared for our h squared, substituted, plus a squared minus 2x plus x squared. And now, what we're going to do is we're going to continue by rearranging this and putting all our basic letters that contain stuff for our triangle together. Now we're going to try to find a way to eliminate x squared. Now, I have a minus x squared here and an x squared here. So what that means is I can cancel these x's. They're gone. And then what we're going to do is we're just going to rearrange all of this so that all our a's, b's, and c's are in order. So we end up with this. Let's call this equation 4. We have a squared plus c squared, and then we have minus 2ax. Now, the reason why I have this equation 4 is because I'm going to try to find some way to get rid of this x term, because all of these variables in here are relating to my triangle. Now, x can be varied, and I don't want that. So what we're going to do is we're going to use our trig identities that we studied a while back, the trig ratios. And what we're going to do is we're going to use the simplest triangle. Now, we're going to use b from the simplest triangle to go and relate the sides of c, a, and x using the tan, cos, and sine functions. So tan of b in this case is going to be h over a, because it's the opposite over the base. And it's not really A. It should be X. And let's continue. And then cos of B is going to be, well, it's going to be X over C. And then we take a look at sine of B, and then we have H over C. Now, you'll notice that I put a no beside sine of B is H over C, because if I went and solved this for H or solved this for C, I'd be reintroducing an H value into this equation. And we want to get rid of this X value and have things in terms of A, B, or C, whether it be the side or the corners. Now, this one here, tan of B is H over X, can't use that either, so we're not going to use it. But this equation, cosine of B, if we solve that for X, we can plug that into here. So let's do that. So we're going to label that as X is equal to cosine of C cosine B, and we're going to label that equation 3. So what we're going to do now is we're going to literally take that information and we're going to sub 3 into equation 4. Now, in doing so, you end up with this equation. B squared equals A squared plus C squared minus 2 times A times that quantity, C cos of B. Oh my. And when we substitute and simplify, we end up with the following. B is equal to A squared plus C squared minus 2A times C cosine of B. And that is that's our relation between the sides. And similarly, you can do the same thing for side A and side C. And we call that the cosine law. And you'll notice that if you think about it, here's A and C, and this B value is directly between those two triangles. It turns out there is a similar triangle representation of triangles. If I can have two sides in an angle and another two sides in an angle that are related, it means that the two triangles are similar or congruent. So basically, the cosine law uses that in order to come up with this basic equation. But I look at this and it's pretty much similar to kind of like similar to Pythagorean theorem on steroids. Because remember how we used to work with Pythagorean theorem. We always had c squared equals a squared plus b squared. Then we had to subtract one side in order to get the other side squared and stuff like that. And we hated that. Now you don't have to do it. This is just the basic Pythagorean theorem for all sides. Now, today's lesson is the cosine law. The cosine law relates any triangle to all three of its sides. Now, here's what you need to know. When you think about it, you got this basic triangle, right? If I was looking at angle B, right? Basically what I have to know is I have to know what A and C are. So there's always a contained angle or an interior angle between these two sides that I need to know the numbers for. And that will allow me to get this last side over here. And that's basically what the cosine law is. Now, the cosine law can be used to solve a triangle. And the reason why I call this the elbow law is because it's kind of like an elbow. The shape that's formed for the cosine law is always kind of like an elbow. So you find an elbow which has a side and angle and a side together all touching, and then you use that in order to calculate. So if I was looking at B, this is what I would be using. But let's say I didn't have the equation in front of me. What I'd have to do is I'd have to say, okay, let's say I was looking at C. If I was looking at angle C, what I'd have to do is I would literally have to do this. Look for the elbow. So my elbow is here. So the equation is going to be B squared plus A squared minus 2 times b times a cosine of the angle c. And that is equal to little c squared. And that's it. And we can use that pattern over and over again and basically not have to memorize these equations. So let's go on to this problem set here. Now, suppose I have a triangle here, okay? And my triangle is ABC. And I look for sine law. So, you know what? The first thing I always do is I check to see if there's a sine sausage somewhere. And clearly there isn't. There isn't a matching angle inside in order for me to use sine law. So the moment I see that, I take a look for my elbow. I look if there's an elbow. If there's an elbow, I'm going to go and use that elbow to calculate this side B here. So my equation for B is this. B squared equals A squared plus C squared minus 2AC cosine of B. Now, subbing directly in, we're going to get B squared is equal to 12 squared plus 15 squared plus this cosine of 70. And now, what we're going to do is we're going to expand this and pull that information together, and we're going to expand this and leave it in front of the cosine of 70. So we get B squared equals 169 plus 255 minus 390 cosine of 70. And so now, in order to get B, we're literally going to square root the result of these two numbers added together, which is this. And we're going to minus 390 cosine of 70, but we're going to have to square root it right away. And in square rooting it, you're going to end up with not 16.1, but you're going to end up with 16 right away. Now that is what B is. So now that I have 16 and 70, now I have my sine sausage that I can use in order to do sine law. So in doing sine law, we start off with B over B being on the right side, so sine of B over B, and we're looking for sine of C. Sorry, either sine of C or sine of A because we have those sides, and this time we're going to use sine of A. Now, substituting in, you're going to get this, which gives us this, and like before, you solve, and you get 50 degrees, and we'll fit that in. Now that we have that, in order to calculate angle C, we just subtract and we end up with 60. Now, let's go over the basics of cosine law again. Cosine law looks something similar to this, except there's no bracket here on these equations. And it's always based on a triangle ABC, but I could also have an EFG and just use the same pattern in order to calculate that, calculate my side. This thing works for all triangles. All you have to do is substitute accordingly. That's it. Now what I'd like you to do is I'd like you to do these pieces of homework from the textbook. Do as many as you can. Questions number 1 and 2. Number 1 is using number 2 is using the cosine line. Number 3 and 4 are about solving triangles. Do a couple of the questions, and then if you got the hang of it, move on to the word problems, which will be 8, 9, 11, and 13, 18, and 19.